talk a little bit about types of waves. There's two main types that we're going to deal with, right? There's transverse waves, and these are just, if you ask somebody to draw a wave, they'll draw a transverse wave. It's like the waves on an ocean, right? If we move the spring up and down, we get these ripples that travel through. These are easy to see, easy to make, right? Longitudinal waves, if we had a slinky, we'd actually move our hand this way, right? And we make expansion, compression, like that, right? So the concept is this, right? With a transverse wave, if say the wave is moving to the right, the medium moves up and down. Okay, in a longitudinal wave, the wave, say, maybe moves to the right, and the medium moves right and left. Right, it moves back and forth. It moves like this, right? Okay, and the way you remember this is that the longitudinal motion is along the direction that it moves. The transverse is like across. So trans means across, like a transect means to draw a straight line across a biological plot, or Trans Am is a car that could drive across the country, right? Transverse means across, right? Okay, so that's that. And then let me just show you, this is a YouTube video that I found. This is a transverse wave, so the things are moving up and down. The longitudinal, it moves side to side like that, right? So up and down, waves moving to the right, but anyway, it's a little hard to see. But that's the basic idea, right, of the waves. I have some demonstrations. So sound is actually a longitudinal wave. A speaker or a drum membrane will move this way and make compressions and expansions and compressions like that. And if you graph that, by the way, if you graph the pressure or the density of the air, you get a nice little thing that looks like a wave, right? But this is a graph of density, right? Here it's highly dense, here it's less dense, right? A surface wave is actually, stuff moves in a circle, and near the bottom it's kind of funny. So it's actually longitudinal and transverse, although we tend to like to think that it's actually just transverse, right? When they break on the shore, though, for sure, they're actually moving up the shoreline, you know. What's interesting also is that tsunamis are actually compression, like sound waves in the water, huge amounts of energy stored in the compression of the water. When they reach land, they do unpredictable things. Sometimes the water will just rise and rise and rise. Sometimes you'll get the towering classic tsunami wave. And they travel really fast. And then there's also electromagnetic waves. These are actually transverse waves, so electric fields and magnetic fields at right angles to each other. These require no medium, which brings up an interesting question. If it's traveling through the vacuum, and let's imagine that you're standing here and you shine a flashlight at me, right? And I run this way. Is that me? Am I running? If I run this way at some speed, do I actually see the light traveling at a speed other than the speed of light? If I run toward it, and if I run away from it, do I see a little bit less speed? And this is something that Einstein actually talked about in special relativity. And the answer, by the way, paradoxically, is that no, it doesn't matter how fast I run toward the beam or away. I always see it going the speed of light. But anyway, they travel at the speed of light. It's independent of the source or the observer. And then these are common ones. So radio waves, microwaves, infrared light, ultraviolet, X-ray, fight, gamma rays, all of those things are electromagnetic waves. We'll do a cheer when we get to class. It's really quite peppy. So this is just sort of a rundown of it, right? Mechanical waves, so shear waves in earthquakes are transverse waves. A building, as a shear wave goes by, as the wave goes like this, buildings go up and down with shear waves. Waves on guitar strings, obviously, surface waves on water are mechanical transverse waves. Longitudinal waves, pressure waves in earthquake waves, right? In a pressure wave, as the wave travels this way, the buildings move this way and this way. They're longitudinal, okay? Sound waves are longitudinal waves. Compression waves on a spring. I really couldn't think of any other ones, right? And then there's nothing goes here, okay? But there definitely is all electromagnetic waves, right? Are transverse electromagnetic waves. So these do not require medium. What that means is that they can travel through a vacuum. Mechanical waves cannot travel through a vacuum. All right, there you go. Thanks for listening.